Welcome to episode 2 of Math and Mice, the mathematics of Disney comics. This time we will talk about Mysteries of Mathematics, or which its original Italian name, Misteri della Matematica, and we will talk about the concept of equality. Misteri della Matematica, Mystery of Math, but it's a short story, a one-pager, with Donald and Feathery Duck, written by François Corteggiani and with the drawings of Giorgio Cavazzano, probably the most famous Italian Disney drawer. It appeared in Topolino 2439, and in the story we see Feathery a little bit puzzled when he meets Donald. To get all the publications of the story, you just go down in the comments and see the link to the index page where you can see that the story has been published in Finnish, in Finland, in France, in Germany, in Greece, in Indonesia, in Italy, and in Portugal. As you can see, it's not been published in any English-speaking country, and so I modified myself the balloons. Not in a very fine way, but just to get it readable. So the story goes like that. Donald meets Feathery, which is a bit of a puzzle, and asks him, "What are you thinking, Feathery? I have a doubt. I don't know how to solve. I always thought 4 and 4 made 8. So what? Yesterday, Daisy told me 8 is equal to 5 and 3. Today on the radio, I heard that to get 8, you must add 6 and 2. I'm getting crazy. Who's telling the truth? Who? Hehe." Donald smiles at the reader, knowing that he and the reader both knows better. And actually, this is just a fun story, a one-page gag, which makes fun of the poor Feathery, who is so dumb. Indeed, even my 5 years older son liked it so much and continues saying, "Oh, Feathery is so dumb, he's so dumb." And indeed, if he was making some much more complicated error, it would have not been so fun. But let's look better into the story. What is equality? Because Feathery is saying something about what 8 is equal to, but what does equal means? Well, if you take it literally, a thing is equal only to itself. A is equal to A. But if you take this philosophical point of view, well, you are not doing any math. You are not getting anywhere. You have to just think that two things may be formally different, but be the same from some point of view, or two things may be different things, but may be formally equal, and so they have something in common. Or even more, some things may be not equal, may be different, but you may want to consider them equal in order to do something. For example, when you consider rigid motion in the plane, then you get the notion of congruent figures in the plane, and this is useful to do some Euclidean geometry. Or you can consider any other kind of group of transformation that brings some figures into others, and just say that the figures who are left invariant by the group of transformation are the same. And this is indeed the definition of geometry by Klein in his program of Erlangen. But let's see two examples here. One is simpler and one is much more complicated. On the bottom left of the video, you can see the fact that the sum of two numbers times the difference of two numbers is as equal to the difference of the squares. And this can be useful in order to when you want to see that something is the difference of two squares and you don't know what it is, by breaking it into a product, you can reason about its prime factorization, and it can lead you somewhere. Or, in the top right of the screen, you can see the definition of variance, which is the expected value of the variance of a random variable is the expected value of the square of the variable itself minus the expected value of the variable, but with some calculation you can see that it's also equal to the expected value of the random variable squared minus the square of the expected value of the variable. And both these two, which are formally different but are the same, are the variance of the variable, are useful. From the definition you can see that the variance must be a positive or zero number, and from the last formula you can see an easy way to compute actually the variance. But let's get back to 8. So Fetter is getting crazy. Who's telling the truth? Who? Well, everyone is telling the truth. And from different things about 8, you can get some more information about 8. You know that 8 is even since it's 4 plus 4, or since it's 2 times 4, that it's a prime power, since 8 is 2 times 2 times 2, and it's the sum of 2 square. Indeed, it's 2 times 2 plus 2 times 2. And it's also the difference of 2 square. It's 3 times 3 minus 1 times 1. And knowing some different equalities gives you different properties of the number. And it can get even more nice when you go to abstract algebra, of course. Just let's keep it somehow to arithmetic. If you got a quantity which is expressed as a sum of integers, both positive and negative, you know that it's an integer. But if you can express the same quantity using a sum of squares of rational numbers, well, then you know that it's both an integer and it's a positive or null number, and so you get that is a natural number. From various equality, rather than losing your head or getting crazy, well, you are learning something, and learning something is always good in math and in life. For this time, it's all. See you next week with Of Math and Mice, the mathematics of Disney comics. See you.